Welcome to Mrs. Miller's notes for her double block algebra class. These are the notes for section 8.3 entitled Graphs of Exponential Functions. And today we're going to make a table of values so that we can graph an exponential function, and then we're going to find its domain and range. Now, an exponential function is a function that has this particular form: y equals a times b to the x. And x is going to be your exponent, so that's why it's an exponential function. And b is going to be your base. Notice here your base has to be greater than 0. Can't be a negative number for your base. But this number out front, this a, that could be a negative number that you would multiply this whole power by. So that could affect your function and get a negative into your function that way. And then it also says that b cannot equal 1. So I'm going to ask you, why can't b equal 1? Because if your base was 1, if you had y equals 1 to the x, if you have 1 to some power, 1 to the first, 1 to the second, 1 to the third, 1 to the fourth, you're just multiplying 1 by itself over and over and over again. So really that's just a horizontal line of y equals 1. That's all that is. And we don't want horizontal functions, we want exponential ones. So what exponential functions do when we graph them is that they increase or decrease rapidly. Now if we graph a horizontal line, that's not increasing or decreasing, that's staying constant. So when we have an exponent in a function that makes the graph increase or decrease rapidly, the graph is going to come close to 0, but it's never actually going to equal 0. And then to graph them, we're going to make a table of values. We're going to use positive and negative values. And then after we graph them, we're going to talk about domain and range. All right, so let's take a look at some graphs here. It says to make a table of values for each exponential function, and then graph it and describe its domain and range. So for part A here, we're going to start off fairly easily. We have 2 to the x. Now, if you need to, you can put in that middle column where you're showing your work. So you could do x, and 2 to the x, and then y. So if you want to write your table that way, you can. But we're always going to pick some positive and some negative values, because this function is going to behave differently for positives and negatives. Usually I say to start between -2 and 2. And I think for most of your functions, those should be okay values to pick. The directions in the book might tell you what numbers to pick. So if that's the case, use those numbers. And I'm going to start down here with the positives, actually. I'm going to do 2 to the second, which is 4. And then 2 to the first, which is 2. 2 to the 0. Remember, anything to a power of 0 is 1. And then 2 to the -1. It's like 1 over 2 to the first, or 1/2. And 2 to the -2. That's going to be 1 over 2 squared, which is 4. So you will get some fractions when you're dealing with exponential functions, and that's okay. They're annoying to graph, but they're not impossible. So we go to -2, 1/4. So just kind of estimate where that would be. -1, 1/2. 0, 1. And then 1, 2. And 2, 4. Oops. 1, 2, 3, 4. There we go. Now you could keep going if you wanted to. You could plug in 3 and 4 and 5. But we have enough points now to see that our graph is going to increase from left to right. Now this part on the left here, this is going to get really, really close to 0, but it's never going to touch it. So we're never going to go across that axis. It's kind of like an electric fence. Okay, so this is definitely a growth function. because it's growing, it's increasing from left to right. We're going uphill. And then we still have to talk about our domain and our range. Now our domain, we can put in any number. Remember, domain is x values. We can put any number we can think of into this function. It can be positive, it can be negative, etc. So we're going to say that's all real numbers. But the domain, the y values, the stuff we get out, yeah, they get closer and closer and closer to 0. They never actually equal 0. And they're never actually negative. So all of these values up here, they're in the top half of the graph, which makes them positive. So we'll say it's all real positive numbers. So just think for that positive in the domain, or I'm sorry, in the range, it's going to be wherever the graph is actually physically located. So the graph is in the top half where all of the y values are positive. So your range is going to be all real positive. If your graph was located down below, that would be all real negative because where all the negative y values are. Okay, let's try the next one. X. And then I'm just going to do y this time. If you want to do that middle column, you can, where you're showing the substitution. And we're going to pick -2 to 2. So we'll have 1/4 squared if we start down here with 2. So remember, when you do that, when you do 1/4 squared, you're distributing that power to the numerator and the denominator. So you get 1/16. If you do 1/4 to the first power, you're just going to get 1/4. Anything to the power of 0 is 0. Oh, I'm sorry, 1. -1, you're going to have, okay, now it would be 1/4 to the -1. So you're going to give the 1 and the 4 both a negative power. Then you're going to have to switch their locations. So the 4 actually comes up and the 1 actually goes down. So you actually end up getting 4/1. 4. And for -2, it's the same thing. That negative exponent kind of flips everything upside down. So you would have 4 squared over 1 squared, which would be 16. Now you can put that into your graphing calculator or your little calculator. Just make sure you have parentheses around the 1/4. And then when you graph, let's see, -2, 16 is not going to fit on the graph, but -1, 4 will, and 0, 1, and 1, 1/4, and 2, 1/16. Oh my goodness, that's going to be really close to the line. So even though we don't have -216 on the graph, we know it's way up here somewhere. So then we would come down and connect all of these points. And there's your graph. Okay, now this graph is going down as it's going from left to right, so this is going to be considered K. And then the domain is still going to be all real numbers. We can put in positive numbers and negative numbers for X. But the range, if we look at the graph itself only exists above the the x-axis. So that's 0. So it's going to be everything that's greater than 0 or all real positives. Okay, we have 2 more. Okay, part C, we're going to do the same thing. We're going to make a table of values, except this time we have a number that's out front. We have that A value. So I'm going to do 5 to the x first, and then whatever I get, I'm going to multiply by -2. Again, we can pick some negatives and some positives. We want to do that because we want to make sure that we're representing all values on the number line on the x-axis. Okay? So let me start down here with the 2. Okay? I would do 5 to the second first, which is 25. Then times the negative 2 would get me negative 50. Okay? So when you're evaluating these, you have to do that exponent first. Sometimes the common mistake is for students to multiply the 5 and the negative 2. But then that messes up all the values that you have. Okay, for the next one, we have 5 to the first, which is 5, times negative 2, which is negative 10. Anything to a power of 0 is 1, but remember, it's just the 5 that's being raised to a power of 0. So then you have 1 times negative 2, which is negative 2. Now, for the negative 1, it just applies to the 5. So you'll have 5 to the negative 1. So that's like negative 2 times 1 over negative 5. So it's 2 divided by 5, basically, which is going to be negative 0.4. Now you can do that on your calculator as well, and you can just write the decimal down so we can graph it. That's okay. And then 5 squared is 25, but it's a negative squared, so it's 1 over 25 times 2 over 15. Oh, sorry, times 2 will get you negative 2 over 25. So that will get you negative 0.08. Okay, so we get real itty-bitty decimals, and again, they're hard to put on the graph, but just estimate. Just do your best. Oops, they're supposed to be negative, though. Going on the wrong side of the number line here. Okay, let's try again. Okay, negative 2, negative 0.8. Negative 1, negative 0.4. 0, negative 2. 1, negative 10. And the other one won't fit on the graph. But we can see that this graph really decreases rapidly. So this is definitely going to be a decay graph. It's going down as you're going from left to right. And the domain, again, is going to be all real positives. The range, it's not up here in the first and second quadrant where our other graphs were. So it's not always going to be positive. Now it's down below. So this is going to be all real negatives. Okay, sample 4, part D here, our 4th graph. This is our last graph, and then we'll take a look at a couple other problems. Now here we have 2/3, and we have it negative out front. So again, it's still going to be negative. It's going to flip the graph upside down like this part C did. We're still going to pick negative 2 to positive 2. So let me start with the 2 down here. I'll have 2 squared and 3 squared, so that will be 4 over 9. But then I have to multiply it by a negative 1, so it's negative 4 over 9. And then I'm going to divide that out and just make it a decimal, negative 0.44. Okay, 2 to the third is to the first power is just going to be 2 to the third, but then it's going to be negative, so that'll be negative 2/3 or negative 0.67. Anything to a power of 0 is 1, but again, remember, it's just that 2/3 to the x that's being raised to the power of 0. So 2/3 to the 0 is 1 times this negative out front gives us a negative 1. Then when we do 2/3 to the negative 1/2, that actually flips the fraction around. So you get 3/2, and then you're going to make it negative. So it's going to be negative 1.5. And for negative 2, you're going to substitute the negative 2 in there. So you'll have 2 to the second and 3 to the second. So you still get 4/9. But since they're both negative, you have to flip them around. And then you have to make the whole expression negative. to actually end up with negative 2.25. So now let's graph negative 2, negative 2.25, negative 1, negative 1.5, 0, negative 1, 1, 2. Okay, so this one's not as sharp as some of the other ones. It's a little more gradual, but it's still close, because as you go from left to right, the graph goes up, and the domain is still going to be all real numbers, but the range is going to be all real numbers, and they're all going to be negative. Oh, that little blue line. One moment. Okay, so let's write our domain and range again now. So this was growth, because we were growing as we went from left to right. And our domain was all real numbers, and then our range was going to be all real negatives, because these were all negative numbers here in our y value. Our graph is staying down here in the negative part of the y-axis. Looks like there's a little red dot there. Where that came from. Okay. So when you see these on your homework, just know that you make a table of values and you graph them. And then example 2 and example 3 are more application thought type ones. Tell whether the graph of the function contains the point. Now this is just basic substitution. Remember, your point is always x, y. So they want you to substitute those values into the function and see if you get a true statement. So y is 1. We'll have 7 times 3/5 to the x value is 0. So now if we actually go through and simplify it, it should pull the same thing on both sides if it is a solution. So anything to a power of 0 is going to be 1. So I have to do that exponent first. Don't multiply the 7 by the 3/5. So I'll have 7 times 1, which is really 1 equals 7 when I multiply. And that's not true. So no, it's no solution. So that order here is not a solution. Doesn't matter if you just put no or not a solution. Doesn't matter to me. So that's just trying to get you to understand that you have to do that exponent part first. So remember those rules from exponents that we've been talking about that we just took a quiz over. And then number 3 here says to use a calculator to evaluate this expression. This is just to make sure that you can put these functions into your calculator. So we're going to substitute the 3.5 for the x. Now again, remember your order of operations here. You have to do that exponent first, then you can multiply. So if you do 2 to the 3/5 power, hit enter, get an answer, multiply that answer by 5, and you should get 56.57 to round. Now they don't tell us what it is. It's just a student score, so we can just leave it like that. We don't need a label on it for this one. Okay, so in this practice set tonight, you're going to have some graphing, so make sure you help yourself to graph paper, and you're going to have some of those application problems that we saw in example 2 and example 3. So if you have any questions, come on by and see me before school.